Hello, everyone. Welcome back from the weekend. I hope it was a great weekend for you. We're going to be starting a new, new unit. We're still in Unit 2, but consider it Part 2 of Unit 2, where we're going to be talking about something called fair division. All right, so just to kind of introduce you to fair division today, we'll talk about a couple of scenarios, common scenarios that you might find yourselves in later on, where you need to take something and you need to divide it up, right? So you can think about two kids sharing a candy bar. Like if you ever had two small kids or siblings and you only had one candy bar to give them, you have to split that candy bar between the two kids. And if one kid feels like their candy bar is smaller than the other kids, they're going to be upset. All right. So splitting assets in a divorce or chopping up land, splitting up money, things like this. These are all situations where we have items of value that need to be divided between two or more people, and we call these scenarios of fair division. All right, and so we're gonna kind of go through these and talk about just some of the rules that we're gonna follow as we develop these fair division methods. Okay, so we say fair division method is a procedure that can be followed that will result in a division of items in a way that each party feels they have received their fair share. Okay, and this is an important word, feels. Okay. They might not receive equal parts of whatever it is you're splitting up. As long as they think they did, we win. Okay, and that's kind of the key here is we need to figure out what they feel is fair. Like what do they think that they're entitled to, and that's where this idea of what a fair share, that's where that idea comes into play. All right, so here's some of the things we need to keep in mind. The parties that we are dividing amongst are non-cooperative. They are not going to work together, so the method must operate without communication between the parties. Okay, so imagine those two kids splitting up the candy bar. They're not talking to each other. They're not trying to help each other out. All right, the parties have no knowledge of what the other players like or what their evaluations of the property or the thing that you're splitting up is. They have no idea what the other person values it as. All right. The parties are always going to act rationally, all right, meaning that they're always going to act in their best interest. They're never going to take less than what they think they are entitled to. They don't make emotional decisions, okay? And the method should allow the parties to make a fair division without requiring an outside arbitrator. So the idea here is that if we follow the rules of the method, everyone's going to walk away happy and we don't need someone to moderate. Okay, so with these methods, each party is always going to be entitled to something that we call a fair share. All right, so for instance, if we had $100 and I'm splitting that between two people, each person would feel like they are entitled to $50. All right, so in a more general sense, if we have a certain number of parties equally dividing something, that fair share would be whatever it is we're dividing divided by the number of people to divide it amongst, right? 1 divided by n. All right, so for example, if there were 4 parties, each would be entitled to a fair share of 25% of the whole thing. Okay, so more specifically, they're entitled to a share that they value, and this is important. Okay, it's how they value it. Each person is going to value this thing differently as long as they get 25% of what they feel the value is. Okay, so let's take a look at a real simple scenario that would help us understand that. Oh, a couple other things. This does not, so one of the things we do not have to do, it does not have to be envy free. So at the end of the day, like if we're splitting up that candy bar between two kids and I use some method to split that up, I give them each their part of the candy bar. They each feel like they got their fair share, but the kid looks over at the other kid and is like, he might have gotten a better piece than me. He might be envious of that piece, but he should be happy with the piece that he got because he feels like he got a fair share. All right, so we do not have to be envy free. The other one is this weird term, Pareto optimal. It's a division. Pareto optimal division is one in which no other division would make a participant better off without making someone else worse off. Okay, so we do not need to be Pareto optimal. Okay, it also doesn't have to be equitable. Not everyone's going to get equal pieces of the thing in the end. All right, that's not a requirement. As long as everyone feels like they got their fair share, that is what we need to go for. All right, let's get to an example here. All right, so this is a very common scenario. We're splitting up a pizza. All right, so they ordered a pizza. The pizza was $12. Okay, so $12, and the pizza is half pepperoni and half veggie. All right, and so we want to figure out what would each person's fair share be. Well, assuming that everyone knows how much money was paid for the pizza, it was $12. Okay, then they would feel like their fair share would be 1/4 of whatever $12 is, right? So we can take that $12 divided by 4, and each person would feel like they are entitled to $3 worth of pizza. Now here's the tricky part. What does each person view is $3 worth of pizza, right? Since they don't value pizza the same, right? Remember, it's half pepperoni, half veggie. Some people might place more value on the pepperoni side of the pizza versus the veggie side of the pizza, or somebody who's vegetarian might value that vegetable side of the pizza much more than they value the pepperoni part of the pizza, right? But at the end of the day, whatever we give each of these 4 classmates, they need to feel like whatever they receive from that pizza is $3 worth of pizza. All right. The tricky part is figuring out what do they each feel each slice is worth. All right. So let's dive a little bit deeper into this. And let's talk about Steve. He's one of the 4 classmates that they need to divide the pizza up. Now remember, each student views the pizza differently. All right. Now remember that the pizza is half pepperoni and half veggie. And it tells us here in the problem that Steve likes pepperoni twice as much as veggie. Okay. And we want to figure out a fair share for Steve. Okay. So we have to envision this pizza. Right. So I'm going to try and draw a pizza here. And so here we have a pizza. And remember, it is half pepperoni. Right, so we can say like this half is pepperoni and this half is the veggie pizza, and let's say this pizza is cut into 8 slices. Okay, so we're just being hypothetical here. Okay, so I'm going to make 8 slices of pizza. There's my 8 slices, and let's say again we said this half was going to be the pepperoni, so I'll put the pepperoni over here. So we'll say this is a pepperoni slice, and I'll just mark these all with P's for the pepperoni slices, and these over here are the veggie slices. And this pizza is not drawn to scale. Okay, so imagine that all of these pieces are the exact same size. All right, so we have our pepperoni slices, we have our veggie slices, and we know that Steve values the pepperoni pizza twice as much as he values the vegetable pizza. But we don't actually have a value for either one. So let's just assign it a value. We'll say that its value is X dollars. Okay, so a veggie slice is worth X dollars. And so I'm going to make each veggie slice here worth X dollars. Okay, which means the pepperoni slices, if they're worth twice as much, these are each going to be worth 2X dollars, right? 2 times whatever the veggie is. So 2X dollars for each of these. Okay, so I'm visualizing this pizza, and I've got Steve's values for each slice of pizza written on each slice. It just helps me think about what's going on here. So if I were to add up the values of these 8 slices, right, we would get 2x plus 2x plus 2x plus 2x, and then our 4 veggie slices, right, x plus x plus x plus x. So there's my 8 slices, and we know that the value of these 8 slices has to equal the total value of the pizza, which is $12. And you'll see that what we've set up here is an equation, right? So this kind of takes us back to our Algebra 1 days, where we have a simple equation here, and we want to know what x is. Okay, so if I add all of these together, right, we would get 12x. So 12x equals 12. All right, and then if I solve this equation, we would find that x equals 1. All right, so each slice of veggie pizza is worth $1. Okay, so we would say 1 veggie slice equals $1, not $12. So he values the veggie slice at $1, which means 1 pep slice, right, 1 pepperoni slice equals $2. Right, because he values those twice as much. These would all be $2. Okay, so if I were trying to find a fair share, right, what could I give Steve that would make Steve happy? Well, I could give him 3 slices of veggie. Right? So 3 veggie slices would make him happy. Okay? He might see somebody walking away with a pepperoni slice, like, man, I wish I had a pepperoni slice. He might be envious of somebody else's pepperoni, but he's going to be happy with this because he got $3 worth of pizza. Another way we could do it, we could do 1 pep slice. 1 pep slice plus 1 veggie slice. Okay, so we could give him 1 slice of veggie, 1 slice of pepperoni. That would be 2 plus 1. That would be $3 worth of pizza as well. So that's another option that we could give Steve, and he would be happy with that as well. Okay, so that's a quick run through of how to do. This is a very quick fair division method where we're manually going through and creating fair shares that Steve would be happy with. And you have to remember, Steve is just one of the people in this scenario. Okay, so we're just making sure that Steve is happy right now. The other 3 classmates we haven't talked about. So let's talk about another one of the classmates. Let's go to Kim. She's another one that's splitting this pizza, but it tells us here that Kim is a vegetarian. Okay, so Kim's a vegetarian, which means she will not eat pepperoni. So I'm going to draw my pizza again. So here's my pizza, and I'm going to split it into 8 slices just like I did before. Okay, and we've got pepperoni, 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 veggie, 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 veggie. And she is a vegetarian, so pepperoni slices are worth $0 to her. Okay, she will not eat these, so these are worthless. And let's just say the veggie pizzas are worth X dollars. Again, we don't know how much she values them at yet, but we'll just assign a random variable to them, and then we know that all of the 8 slices has to add up to 12. So 0 4 times is just 0, and then x 4 times is 4x, and we know that that has to equal 12. So it tells us that she values the veggie slices at $3, right? So 1 slice of veggie pizza is equal to $3, and that would be her fair share. So a fair share for Kim would be 1 slice of veggie pizza. All right, so she would get a slice of veggie pizza, and she might be over there watching Steve walk away with 3 slices of veggie pizza, but she's like, well, I got my fair share, and she doesn't really know what Steve's valuations are. So she can be envious of Steve's share, but she can't be upset about it. Okay, so she got her fair share, so she has to accept her share and walk away happy. All right, so that is an intro to what we're doing in this unit. We're trying to find ways to split things up so that everyone walks away happy with what they feel is their fair share. And we're going to take a look at more complicated methods, more complicated situations in the future. All right, guys, that's it for today. Have a great day. Give the practice problems a try, and let me know if you have questions.